All right, get ready for the hand clap. Raise your hand if you saw something special. Awesome. I want you guys to take a look at Christian's work. And disclaimer, Christian, he has pretty messy handwriting, but we're going to try to just like decipher his work here. I know. So let's take a look at his algebraic work. What method is he trying to use to solve this algebraically? Love the hands that I see. Track. Omari. Voice.
He's using elimination.
How can you tell?
I can tell because he puts the equations on top of each other, then subtracts to
So subtracts to get 0, 0? Nope. He is using elimination, but he's not subtracting then. Track Christian, explain your work, please.
Well, the first thing I had to do was multiply Catherine's equation by 2 so that I could eliminate one of the variables. Then I got that the equations are the same thing. So I subtracted and I got that 0 equals 0.
Good. How is this a little bit weird or different from what we're used to? He did elimination, that was fine, but how is this different from what we're used to? Track Angel.
It's different because back then there used to be interceptions, but now there's no interception because we're talking about there's an infinite solution they're going through.
Talk to Angel. He brought some interesting points up. Talk to him. Track Nigel.
I disagree when you say I disagree with you when you say that there's no point of intersection, because with infinite solutions, every point on the graph is the point of intersection.
So I'm really confused because you guys are starting talking about infinite solutions and no solutions, but I'm not even sure why. Why are people starting to bring that up? Track Sahara.
We're starting to bring that up because in Christian's work we see that when he did elimination, everything canceled out. So and then he got 0 equals to 0, and usually for infinite solutions, you see at the end you see 0 equals to 0, and this is different because usually during the elimination strategy, everything doesn't cancel out. You usually have some x equal to something, so you can substitute it in for y.
Yeah, awesome. I completely agree with you. Build onto her answer. Track Brianna.
I would like to build off of you, Sahara, and I agree with you when you say that everything cancels out. But you could also look at the table itself and notice it was going to be infinite solutions, because if you look at Allie and then you look at Catherine, you could divide everything by Allie by 2, and then you would get 2 hours, $3 and $24. So it was like when you convert to slope intercept one, for each you would get y equals -2 times x plus 8. So you would know that when you graph it, it's going to be on the same line.
Well, I'm hearing so much really strong strategy. So Brianna's trying to look at it by inspection and kind of seeing when you have the same equations. But I really want to also hone in on what Sahara said too. At the end, we get 0, 0, and we know, we remember from last time, whenever we solve and get 0, 0, we have how many solutions? I want to, Brianna, love that your hands right back up after that spectacular answer. Track Precious. You'll have infinite solutions. Now let's look at the graph. What do you guys notice about the graph? Track Kaylin A. Right, and there's the same line that's overlapping. What does that mean about their intersection points? Track Jaheem.
That means that since they're overlapping, that means that their intersection point is at every single point, because considering they're overlapping, both lines meet at every single point.
Awesome. They're overlapping, they're meeting at every single point there. So you can assume this has how many solutions then? Sincere? Infinite. This one has infinite solutions. I want you guys thinking about how we knew that algebraically. We're going to move on now. Let's move on to Alasia's work. Did I take your work, Alasia? No? Okay. And you can add one to Christian for his beautiful work. So now we're going to look at Alasia's work. When she graphs it, what do you see? Talk about the types of lines you see and the kind of assumption you can make at the end. Be ready to build off the next person. Track Jihad. Voice Jihad.
See that the lines did not intersect in any points, which means like they have no solution.
Build off. There's something you could add to that answer to make it perfect. Track. Who have I not heard from yet? Track Naeem.
I agree with you, Jahal, when you notice that there is no intersecting points basically since the two lines have the same slope, the lines are parallel to one another.
Great. What kind of lines are these? Back to Jihad. So then what do you know about their equations, Jihad?
You know that they are like the same. They have the same slope in different lines.
Awesome. So they're never going to intersect. So then how many solutions does this one have, Nigel?
This has no solution.
This one has no solutions. Think about how you knew that algebraically to determine that there were no solutions. Now turn over your papers. We're going to start making some conjectures and thinking about when we're solving systems of equations, how will we know when we have infinite solutions and no solutions just by solving algebraically? Write your conjectures down. How will we know just by solving algebraically whether we have infinite solutions or no solutions? Loving the quick pencil to paper. I love that Jada is including the result. She's talking about the outcome in her response. Naeem's talking about the structure of the equation. Tell me how you will know. Is that how you spell no? This better be a nice, complete response. Okay. Can you talk about what the lines are called? Ooh, we did not talk about what the lines are called for the first one. Bonus point for the person who remembers the name of those lines and includes it in their response. So you said infinite coincident lines. So then what kind of solutions for parallel lines? Oh, you have that, okay. Yes,
How do you spell, is it coincident?
coincident, yeah. So it's that the word you're looking for? Okay. Jada. Great, now talk about the algebraic outcome. Like what did we see at the end? What kind of statements for each of those?
Did you realize that this problem is actually half of this one?
I didn't. What do you mean? Oh, like these two? Yeah,
like
Brianna.
the numbers, they're like half.
Brianna brought that up, right? Because it's just like a simplified version. So why does it make sense then that they were coincident?
I said, you know, if you have infinite solutions, because your two equations will equal each other once you find your solution, and one will be half of the other one.
Always.
Yeah.
Think about that. Not always half of it. Think about why that doesn't work. Brianna, track me in 5, 4, 3, 2, and 1. I want to have a really good discussion around this. So first, someone start us off about when do you know you'll have no solution or infinite solutions. Get us started. Track Sydney, nice and loud.
If the coefficients are the same, but the constants differ, there are no solutions. And if the coefficients and constants are the same, there are infinite solutions.
Build off our answer. Let's hear some nice habits of discussion. Track Sadi. Jasmine, you're up next.
Is that if you graph it, if your lines intersect at every point, which means they're coincidental, then you will know that they're infinite solutions. And if your line doesn't touch at all, meaning that you have two lines that don't touch at all, and that means they're parallel, and that means you have no solutions.
Jasmine,
I agree. And
I should be on her.
I agree, and also
if you have an outcome with no solution, whatever you substitute for x and y will cause the equation to be untrue, and the lines are going to be parallel. But for a system that has infinite solutions, the outcomes will be 0 equals 0, meaning that whatever you substitute for x and y will make the equation true, and the lines will be coincidental since they intersect the out point.
Great. So who can give me a statement talking about what they hear from each of your students and each of your peers and make a nice one statement? Raise your hand if your conjecture held true from what you said before. Awesome. Let's go right to our stamp. So we're going to stamp this, and I want one person to give me a beautiful, beautiful stamp. You can now to Sarah for her nice response. Who have I not heard much from today? Kaylin. So we're going to start, if you algebraically solve a system. How do you know if it's infinite or no solutions? Kaylin.
If you algebraically solve a system, you'll know that it's infinite if...
Let's say we know that it has infinite solutions if...